Hello and welcome. Today we're going to talk about our Performance Monitor product for Oracle MS SQL and PostgreSQL. Some facts about our system. It enables you to efficiently pinpoint the causes of performance problems in your databases. Its impact on database load is imperceptible while collecting its operation parameters. The system has no access to and does not analyze the business data. Through regular updates and manufacturer support, handling of the latest database versions is ensured. An intuitive user interface and easy navigation, also for people without technical expertise. On the screen, you can see the main monitor console, where all the connected databases that you want to monitor are shown. The software monitors the three database engines mentioned at the beginning of the presentation. With all databases configured, we are able to quickly identify if there are performance problems and view the alerts that the Performance Monitor sends. This is one of the features that distinguish the DBPLUS Performance Monitor. I'm going to show you how this tool works with the Oracle database. For this purpose, I'm going to go to the ERP database to perform a quick audit of its performance. For the record, I would like to add that our software works with Active Directory, so that users can be granted access rights to selected databases and to selected functions in our software. Clicking on the selected database allows us to see the details of the database. We're now looking at the last 15 minutes of CPU utilization. We can see what the weights were like, with details of performance counters, sessions, and many other parameters. The heart of our monitor is database analysis, which we are going to now. The first thing to see in database analysis is the Database Load tab. It presents the key performance statistics of databases in the selected period. We can verify performance for specific times, days, or other defined time periods. Clicking on a selected point enables me to see the SQL queries that generated that point in time. For the selected query, I will see its content and execution plan. To enter the SQL details now, hover the cursor over the value in the hash value column of our SQL query, and a plus appears. The plus allows you to go to a detailed analysis of the query in SQL details and see since when the query has been launched. I can see that this query has many execution plans, but as we can see, the duration of the query for each plan is not much different, so changing the plan does not affect its performance. I just showed you one of the quick audit methods for SQL queries, and now we will carry out a thorough performance analysis. We're launching Load Trends. This tab allows us to monitor the performance of the database both in the short and very long term. I want to see the performance of this database for the last 5 years. For this, I'll choose 5 years back. I'll click the Refresh button and see what the duration of all queries in the database for the last 5 years looks like. We can see that it is increasing. I want to see the other parameters as well, and I will add them to the chart. I'm adding CPU time. I can also add the weights, locks, sessions. When you add another indicator, additional series are automatically displayed on the chart. However, adding too many KPIs to the chart makes it no longer readable, so you have to keep common sense everywhere. Can I improve performance by adding more CPUs or more IOs? Well, we must first see if the number of sessions is increasing. As you can see in the chart, the number of sessions is increasing. So is it blocking the CPU? Or is there enough of them? To see if we have enough processors, click on the OS Stat tab, where you can see the number of processors available for the database. And I can also see through the busy time parameters how much CPU our database uses. As we can see, adding more CPUs here will not improve performance because we're using 183 out of 512. Let's go to the disk check then. Will faster drives affect database performance? We go into the I/O stat options to see what it looks like today. I can see the block read time, and I can tell that there was no trouble for a single data block. Block read time for a single data block remains below half a millisecond. This means there are high-performance SSDs here. I can see what the situation with the disks was like in the long run. Here we can see that there were performance problems with the drives on the 27th at 1456. Now we have to answer the question whether it was a database problem or an infrastructure problem. To answer this question, we need to see if more reads were performed at the same time. As you can see, there weren't any. There were fewer reads than in the peak. Were more writes done? We can see that more writes were not done. So we can conclude that it was a problem with the infrastructure. Now we can see if this infrastructure problem, which happened on the 27th at 2:56 p.m., had an impact on performance and the databases. We can do this in several ways. The first one is to go back to database load and display data for July 27th. We will see if there were performance problems or not. As you can see in the chart, there were performance problems. The pink line went up. On the pink line, you can see I/O, lock, wait time, and by clicking on it, you can see a whole lot of queries that slow down. The first query that slowed down is insert. We can see what the alerts were at that time. We have a red dot on the chart that indicates alerts. We are going to click on it. We get quite a comprehensive description of the situation, i.e., we can see that at the time when there were disk problems, we can see a large number of blocked queries, which is natural in this case. When all queries slow down, the number of locks will be significantly higher. Of course, we can go to the locks on the 27th and see what locks occurred then. We can see the locks, and in our tool, we can click on them and see which session was the blocker, what the locked query tried to do. The blocker tried to do an insert, but it was the disks that stopped the insert, and this led to other queries being locked. So these locks didn't cause performance problems. The reason for the performance problems is definitely the disk problem we discussed and which was visible in our I/Os. Please note that this is our performance problem, i.e., the read time of a single block of data has slowed down from half a millisecond to 10 milliseconds. So the block read time was 20 times longer. As soon as this problem was solved by the administrators, we see further that after 1511, that the database performance on that day came back to normal and the locks no longer occurred. So we can go back to the Load Trends tab to check if we can see these July situations here. I'm going to check them by time. And as you can see, there are two peaks in the chart. The first one was on July 25th, and the second peak was on July 27th. We dig deeper, and what we see is trouble with the disk. We can also mark the I/O waits that appear on the chart, and we can see an increase in I/O operations on the yellow line. Of course, there were also locks at that time, but as we can see in the graph, they were much smaller than the yellow line. Our performance problem was definitely with the disks. The number of active sessions at that time also increased because the active sessions could not perform queries due to lack of access to fast disks, so they waited longer to be handled. As I have shown you, a brief analysis of the database carried out using our DBPLUS Performance Monitor tool allowed us to quickly identify the cause of performance problems. As I showed you earlier, we have another performance problem on July 25th. And here too, we can check if it was a problem with I/O waits. We can see that I/O waits are a flat line, so it wasn't that kind of problem. But you can see that there was a high level of locks. If we check all the waits, the locks are 100% responsible for them. In this case, we can enter the lock menu. We are going to select a period to display July 25 only. We can select the day we are interested in and click on a particular lock point to identify which session was responsible for the lock. And what do we see? The blocker was the session that was killed. We can see the status killed. The session had to perform many transactions that had to be revoked after the kill command was executed. Before the changes made by the session were withdrawn, the database locked out other sessions. This resulted in a list of sessions awaiting withdrawal of the transactions. This is all the more unlucky because the sequences are set via select for update. So we have a big performance problem and a huge impact on the performance of other users. This problem will be visible until the killed session finishes withdrawing all transactions. Here we see the insert command from the killed session, which is the last command that was executed by that session, but before that the update or delete or select for update commands on the SEQ table had to be executed. As you can see, using the tool, we are able to easily determine any reason for a drop in the performance of the monitored database. Let's see if there were any other performance problems and what their cause was. Let's find another case. Let's pick the one from July 16th at 1200. As we can see this time, it's not the locks that caused the problem. Again, I can see there were I/O waits, the yellow line on the chart. Again, we enter the I/O stats menu to see the 16th at 12 o'clock. Now, I'm going to set up the chart from the 15th and see if it was a performance problem too. We have a problem, a smaller one of course, but we'll also verify it. We can see at this case that at 12 o'clock, the disk slowed down 6 times from half a millisecond to 3 milliseconds. But that was enough for us to see the performance problem right away. If there are a lot of sessions in the environment, this problem will immediately affect the user's work. We can check what you see in the database load on the 16th. We refresh the chart and we can see a red dot for the alert. So our software has diagnosed it well by describing the problem as data reads time problem caused by slow response. Here, we can see that we should look for the causes of such problems in the infrastructure. To sum up, we can see that in July we have 2 performance problems and their causes are outside the database. Our analysis has clearly shown that the so-called database performance problems have various causes that are often poorly diagnosed and thus long unresolved. The DBPLUS Performance Monitor allows you to eliminate such situations completely. Now, let's go back to SQL Queries Analysis and go to SQL Analyze. We'll redefine our date range again. We see elapsed timelines for all queries that are sorted by duration in the period in question. Clicking on the query below the graph shows us how much the selected query weighs in relation to the entire database. We can see here that the heaviest query weighs 4 to 5%. We can, of course, select any of the queries for analysis. As I mentioned before, in the hash value and SQL ID columns, where you hover the mouse pointer over them, there is a plus sign displayed. By clicking on it, you can choose View SQL Details, then the statistics for the query can be displayed. There is definitely more functionality here. Among them is Find SQL, which we are going to choose. We can access a functionality called Plan Flip-Flop Statements. This functionality allows us to find queries that change the execution plan for the selected range. The report is sorted by elapsed time. After selecting the first query, we can see that this query works with 2 execution plans. With the faster plan, it lasts 16 seconds. With the slower plan, it lasts an hour and a half. Of course, we can compare these plans with each other. To do this, I have to select Group by Hour, and now I can go to Compare Plans to compare the execution plans. On the right, we can see the slower plan, and on the left, the faster plan. Our system has marked the differences between the plans in yellow. The slower one is performed by the nested loops operator, the faster one by hash join. If I want to point out possible problems to someone, I can send the comparison. I can click Print Preview, a second full text window appears, and I can copy and email its contents. Latches. Information about latches is available on the Latches tab. We can monitor latches, row cache objects, and latch library cache. The latch library cache, as you know, is associated with the shared pool memory area containing the Oracle library cache, which is responsible for executing all SQL statements pertaining to the Oracle database. In the presented database, the latch library cache problem is not present. If it was present, you should look for queries that have a large number of versions in the shared pool memory, and so take up a lot of space in it. We have queries in our database, the size of which in memory is 1.6 gigabytes for 9,000 different versions. We also have an insert query that takes half a gigabyte with over 82,000 versions, and many others that take up space in shared pool memory. We can start checking the occupancy by selecting a query from the list. Then click the Show Statement Versions checkbox. This gives us access to the contents of the query for all its versions. We will be able to check where versions are different from each other and why each of them is stored separately in the shared pool memory. The most common reason is the content of literals instead of bind variables in the query. The problem can be solved by passing them back to development in order to replace the literals with bind variables. A query containing literals means that each query is saved separately, which causes problems with access to the shared pool memory. As a result, user sessions start to latch, and the performance of the database decreases. Of course, inserting bind variables instead of literals into queries may also have the opposite effect, i.e., a performance drop. The reason for this is a worse plan to execute a query with variables instead of literals. In this case, it is always easier to optimize the query than to reduce the number of latches. In order to reduce latches, it is absolutely necessary to eliminate those queries that take too much space in the shared pool. Elimination is only possible by reducing the number of versions of the query. Let's now talk about a situation where we want to compare selected days in terms of performance. Compare is a functionality that allows us to compare days in terms of performance. Someone says to the IT department, "Performance today was 15 times worse than last year in May." Then we can choose the days indicated and see if it is true. As you can see in the chart, there is a significant difference in elapsed time statistics for that day. We can, of course, check various indicators that tell us about the performance of the database, such as CPU utilization. We can change the days as we wish, and we can select indicators for the chart to quickly evaluate the performance history. The graph shows the differences in performance for each day for the performance indicators presented. In the Compare Periods functionality, you can compare and contrast individual periods, weeks to weeks, months to months. Let's now move on to the SQL 3D functionality that allows us to search for non-optimal queries. On the selected day, I can see a query that stands out as a big peak on the chart. I can see what caused the drop in performance. As you can see, this query is running continuously. It is very fast because it takes, and suddenly there is a drop in performance. The query takes 6 milliseconds instead of 1/10 milliseconds. It slows down 60 times. So, what happened? Elapsed time, as you can see, slowed down for all executions. We can check to see if it is possibly caused by running the query more than once. No, it wasn't the case. So, what really happened? We'll go to the Weights tab and we'll surely find the reason. We're in the Weights tab and we see the library cache lock. This means that the compilation of objects was certainly taking place while users were working. This must have led to a longer execution time for the SQL query. Don't do such things while users are working. You can see that the administrator noticed that suddenly the number of sessions went up and stopped the compiling of objects immediately, and the database has returned to its performance. As you can see, with our tool, we can check what caused the problems that occurred in the past. I will now show you how we can monitor changes in the database size. With this tool, you can see how the database size has grown over a period of 5 years. I'm going to choose the respective dates, and on the chart, we can see that 5 years ago, the database size was 7.4 TB, and at the moment, the size of the database is 23 TB. The analysis is possible for table-space data files or for individual objects. As you can see, by accessing this information about the individual objects in the database, we can see what causes an increase in database size. Based on such data, we can, for example, plan the necessary changes in the capacity of our infrastructure in the near future. The Memory menu provides basic information on memory configuration. But what's more important is that we have a history of the occupancy of individual memory buffers. The database administrator in charge of the Oracle database sees the shared pool utilization. If they see that the chart is fairly moderate, they know that there are no latches. If the chart was very jagged, we know that there were latches and that we should analyze it. And this is the analysis I showed you in our presentation a few minutes earlier. One of the more interesting features of our performance monitor is automatic monitoring and error analysis. Let's go to the Anomaly Monitor menu and choose the date range that we are interested in. After clicking the Refresh button, we will get the performance problems analyzed by class, for example, network. We will see what kind of a network problem occurred on the 21st. We can click on it, and we will see that the problem occurred at 10:30 and another one at 13:17. I can click on the selected problem and see that there was a data request through the TCP socket network, KGAS, and how much larger it was compared to previous periods. The TCP socket waits, KGAS, as I said before, occurred when queries are waiting to be answered by remote databases. I can check if there was a problem pertaining to a change in the execution plan here. But I don't see it here, so there was no change in the execution plan large enough to change the database load trend. We analyzed a case where there was a change in the execution plan, and we saw some indexes there. Changing the execution plan had no impact on the overall database load trend. It only affected the execution time of a single query. Of course, the user who ran that query noticed a performance drop. In order to quickly identify such events, we added the report I mentioned to you to our system. In the Performance tab, there is the SQL Details tab, and this is the Plan Flip-Flop Statement report. There are other functionalities like queries using plan objects, statements using objects. For example, I can search for an index, and if this index is not used in other queries. I am already closer to the answer whether I can remove it to improve the execution of the query. The report shows whether the object in question is used in multiple queries. The Performance Monitor checks it through the execution plans that are stored in the database for each query launched in the database. We just got word that something is happening with another database. That means I have to do an analysis of it right now. We are going to select the database by clicking the database symbol on the blue bar where the menu with monitored databases will expand. We'll choose the eBASA database. We'll start by displaying load trends and see if there were any performance problems in July. Here I can see that everything is working fine. There were no deviations from the norm, so we can go back much more in time and check the performance in the longer period. However, we can see that there were performance problems on June 22nd, May 18th, or 11th. So, can we analyze April 18 and find out what caused the problems? Of course we can. This is one of the basic capabilities of our monitor. We can launch the SQL 3D tab and select the period from the 16th to the 20th to perform the analysis. We need to display statistics sorted by day. We're going to click Refresh, and we can see that there are queries that have slowed down. We can now check what happened to those queries in April. Were the execution plans changed for these queries? I can see here that they were changed. We can see what they look like right away, but the selected query, despite the change in the execution plan, was executed in a comparable time, up to 2 microseconds. The next query we can see is our problem. As we can see, the execution plan can change from 13 milliseconds to 137 seconds. So our performance problem could definitely be here. Let's move on to the 18th to confirm whether this was really a change of plan for this query. Now we can see everything. On April 18, the query used several execution plans, including slow plans, and this was the reason for the performance problems. Please have a look at this value. The query took 4.8 million seconds, which is a very long time. What can we check and what problems can we identify? Click the Graph tab to check which execution plan was the longest. As you can see, the longest query was on the green execution plan. Let's see it on another chart. We will extend the period and display how this query was performed in the selected period. Now we can see what happened with this query on the 18th, and we can see that it ran very slowly. I'm going to display a chart without execution plans to see this query against the entire database. Now we have a full view. The green line is the time of execution of all commands in the database. The yellow line shows how long the analyzed query took to execute. So, this query represented on the 18th. The conclusion is obvious. We need to optimize this SQL query. How can we do that? We can see it's a matter of the execution plan. The plan with ID 336 is quick, any other is slower. We can see the differences. We must implement the best execution plan. You will be able to make such a change directly from our tool at the end of the fourth quarter of 2020. At the moment, what you get is a browser of the execution plan with an indication which plan is faster and which one is slower. It is worth noting that we have a functionality in the system where we can show whether outlines, SQL profiles, or SQL baselines are created in the database. If they are created, you can see which queries use them. The DBPLUS Performance Monitor also enables reading and reporting of database parameters. If there is a change in a parameter, it is recorded. And, as you can see here, for example, the sessions parameter, we can see what values were set for this parameter. We also have a backup browser, but please note these are RMAN backups only. Let's go back to the Sessions tab to see active sessions in the database. I will return to the previously audited database where more interesting data comparisons are available. We are going to click the Session Sort Undo History tab to find more sessions that use the most resources. Now it's clear which queries changed the most records in Undo, and instantly I have the session that made the most changes. We can now choose such a query and see that the query today has inserted. I can, of course, check if the query works the same way in the long term. I can see that this query puts. At the end of our presentation, let's go back to the I/O Stats menu with the browser. With it, we can see the duration of operations, such as reading and writing, which allows us to determine whether the performance problem is generated by the I/Os, is related to the database, or to the infrastructure. We can display the number of archive logs generated for the selected period. If I wanted to extend this period, then I can follow the same procedure as we have seen in other reports and select the desired date range. Clicking a date will show me the details for that one day. We can see that a lot of archive logs are created, as much as 1.5 terabytes a day. If we have a standby database configured, we can also run our monitoring. We can continue our performance analysis and use the Days Compare functionality to identify performance problems day to day. We can remember that on the 16th and 27th, there were performance problems, but we don't see them here. Why is this happening? We have to choose on the chart that we are interested in the data block read time. Now you can clearly see the difference. We can see performance problems that occurred on the 16th, the green line, and the pink line shows us the performance problems of the 27th. We can definitely confirm that if there was a performance problem on the database side, there would be peaks that would overlap with the longer read time. But, as we can see here, there are none. I have presented to you the DBPLUS Performance Monitor and carried out an analysis of the causes of performance problems in our sample database for you. Thank you for your attention, and feel free to visit our website www.dbplus.pl and to contact us. See you later in another presentation.